Welcome back to another video from Performance Line Bearings. Today we're going to be having a look at the Brose motor. We're going to pull one of these apart and see how it is to overhaul it. So just to show you what we're going to be working with, this motor is a fairly good condition motor and it's very free and very quiet. So the one we're going to be overhauling is very stiff and very noisy, so hopefully we'll find some good damage in there to have a look at. So before we do anything, the first thing we've got to do is to release the belt tension screw. We'll do that before we take the cover off, just to release the tension on the drive belt. So we get the cover off itself. A little security sticker over one of the screws. We've got 6 screws that are going to take the cover off. This motor is obviously out of warranty, so we haven't really got to worry about that. We'll go ahead and take those screws out. So we've got our 6 screws out. Now we have to release the cover. Now there is a gasket that runs around this face that if you break it, you've either got to make another one by hand, or you can buy the Brose kit to replace this gasket. It comes with a belt and a seal, and currently is about £115, so be careful. To try and limit the damage to this gasket, if you just open up the cover slightly and then use something sharp like a Stanley knife blade or something, if you use the back of the blade so you don't cut the gasket, and if it's stuck to both the surfaces, you can gently go along the side of the gasket and just lever it away until you've got a gap all the way round, and then we can take the cover off. Okay, looking inside the motor, we can see that there's been a lot of water ingress. We've got rust inside the cover, and the rust is actually coming from the bearing behind the pulley wheel. You can see rust stains on the outside of that. There's a lot of belt dust in here, but no major damage yet. The drive bearing is good. So I'll just pop the pulley wheel off. Sorry, the tensioner. Got a bit of rust behind that. And get the belt out of the way. So next thing we've got to do is remove the crankshaft assembly from the motor itself. Just before we take this out, now we've got the belt off, we can spin this pulley wheel, and you'll hear that this motor's got a few problems. Everything is pretty nasty in there, so it's going to be a good one for us to look at. Normally we can just turn the motor around and with a soft face mallet knock the crankshaft out. This one is so seized in there, it's not having any of that, so we're going to have to press this out on the shop press. We've set the motor up on the shop press now, and we're going to try and press this crankshaft out. just want to show you what's been going on inside here. As you can see, the water's come through the left hand crankshaft bearing and basically just filled the motor up. The electric motor, because of the angle that the motor sits at in the bike, has actually survived, but all the bearings on the crankshaft are completely destroyed. We have the left hand crankshaft bearing. There's almost nothing left of it, but we'll take the rest of the bearings out and have a look, so show you. So pull the pulley off the crankshaft, and as a testament to Brose, this motor was still working, but you can see from the state of that sprag bearing that there's almost nothing left. We have a wave washer underneath that, and then what's left of another bearing. We'll have a look at that in more detail in a minute. What we're going to do now is we'll set this up on a puller to remove the right hand crankshaft bearing. So we've set up a 2-jaw bearing puller to take off the right hand crankshaft bearing. That's our right hand crankshaft bearing, and surprisingly feels a little bit grumbly, but it's not as bad as the rest of them. So we're now going to remove this part from the sprag bearing that's inside the pulley gear. It's worth noting that this is again a one-way bearing, and it should spin anti-clockwise when the pulley's facing away from you. And again, an absolute mess inside. So now we've got to remove this sprag bearing, or what's left of it, and to do that I normally use just a small pick, but a small screwdriver, anything like that. Now, Brose use a plastic cage bearing, which unfortunately tends to fall apart sometimes, but there's our sprag bearing out, and obviously this would need all cleaning up, which we'll do in a minute. So we've now set up a 2-jaw puller to remove this big bearing that goes around the pulley wheel. We're going to have a go at getting that out. We need something to sit on the aluminium face inside the bearing to push against, and this may be a bit tough. So we've now removed that bearing, and again, as you can see from the state of it, it's completely had it. In order to get this bearing race out, we're going to flick the bearing out and then heat this area up so that the aluminium expands more than the steel race, and then press it out so that we can get the new bearing back in. So to get this bearing out again, we can just break it up. So that's our bearing out. We're going to now press out that collar once we've heated this up. So to get this bearing race out, we're going to use a 40mm press bit. So this is our bearing race that will probably need a lot of cleaning up, and we'll move on to the next bit. Next we're going to remove the left hand crankshaft bearing, and to do that in this case, because it's fairly well rusted onto the crankshaft itself, we put a bearing splitter on just loosely so that we can press that out. So that's what's left of our left hand crankshaft bearing. So now my assistant's picked the bearing up. That's our left hand crankshaft bearing. That's off, out of the way. So now we can remove the pickup collar from the shaft, and again we can see a lot of damage to the actual pickups themselves. I would be worried about this going any further, but we'll carry on. The next bearing on the crankshaft is the middle support bearing. This is what's left of it, and again we can hear that that's very poor. It's very tight to the crankshaft at the bottom there, so in this case we're going to use the bearing splitter for the job it was intended for. Wow. I'm going to have a bit of a problem getting this off here. The bearing's absolutely collapsed, and we need to still get this collar off of here. So as you saw in the last shot, the bearing collapsed, the outer race came off, all the balls came out, and we're just left with the inner race on the shaft itself. So what we've done is ground down the inner race, not till we touch the shaft, but just ground some material out of it, and then hit it against a hard surface, and we put a crack in the bearing race, and then we can just get the chisel in there and start easing the bearing race off the shaft. So finally we've eased that off with the chisel and screwdriver, and that's what's left of that bearing. So the last bearing we've got to worry about, have a look at this in this stage, is there's a needle roller bearing in there that sits in the chain wheel body and runs on the crankshaft itself. So we're going to press this needle roller out of that unit. So we're set up in the press. And this is the needle roller bearing, and again, as you can probably see, it's completely destroyed. As you can see by the state of these, that if your motor does start making a noise and you disregard it and carry on riding, this is what you're going to end up with. It will be just completely scrap. You can see one of the main things here is this needle roller runs on that bearing surface on the crankshaft. But bear in mind that none of the parts, the components for this motor are available from Brose, that if this is damaged, your motor is scrapped. At Performance Line Bearings we do hold a small amount of second-hand parts, but they are very limited. Now this bearing surface takes the needle rollers of that bearing, so if you put a new bearing on top of this, it won't last 5 minutes. It's just pointless doing it. So again, it's game over. There's not really any point in taking off this side of the motor. There's basically nothing that can be done. When that cover comes off, it's just a printed circuit board that plugs onto the back of the electric motor. Maybe if you've got wiring terminal problems, that would be the only time you take it off. Under here is your 3 planetary gears that run your electric motor on this shaft. There's nothing that can be done with this currently. The actual gear shaft itself is pressed in, and then a magnet is capped over on the end, and it can't, you know, it's a one-shot deal, so we can't get these, we can't fix them at the moment. So if any problems in here, that's it, it's a new motor. Okay, we've got everything cleaned up now. We're going to start putting new bearings back in the motor to get the motor back in operable condition. So first one we got to put back in is the sprag bearing back into the motor housing. We just put a little into the pulley housing. We just put a little smear of grease into there. Put the sprag bearing back in with the little pulls flowing in an anti-clockwise direction. And we can press this back into that housing. So that's our sprag bearing back in, and now we've got to put the large main bearing, and we'll press that back onto there. Feeling better already. We've just cleaned some of the grease and rust out of the way, and we can see that the bearing surface on here is almost absolutely destroyed. This will work because it's a sprag clutch bearing, but it's really going to feel rough and horrible, so we're going to change this for a new part. So we have a good second-hand part now, and the first thing we're going to do is replace the needle roller bearing. This is the one we took out of the old motor that's destroyed. The only problem is you can't get these, you can't buy them anywhere. They are Brose specific, and as of yet we've not had them made. So what we've done is we've replaced that with 2 thinner needle roller bearings that make up the same dimension. They also make up the same bearing surface because the needles in this are quite small. They do have 2 rubber seals either side. Obviously this is supposed to stop water ingress. These rubber seals are primarily to stop the grease escaping. So what we do is we insert a proper seal into this part to stop the water actually getting past it, and the seal must be lip down. So basically, once it's inserted into the part here, any water coming down the middle can't get past this seal into these bearings. So the first thing we're going to do is drop the seal in, and it's very important that the seal lip is facing down, so the back of the seal is facing up, so any water coming down here is going to hit the lip of the seal. Once we're happy that's all the way down, we can now press the bearings in. And do them one at a time. Do this very gently, hardly any pressure on the press, just till we feel it touch the seal. Once we're happy that that's seated properly, then we can drop the second bearing in. Make sure we're all lined up. And again, just touch the bearing below. So now we've got the two bearings and the seal with the lip pointing away from us. Put a little bit of grease in there. We're good to go. We're going to assemble these two parts together now. I'll put a bit of grease on the new sprag bearing. Okay, now what we'll do is we'll set it up on the press to push on the right hand crank bearing. So we've set the bearing up in the press, and we're going to press this onto the shaft, but it doesn't go all the way down to the bottom. It's 17mm from the threads at the top. So what we're going to do is we're going to put a 4mm drill in there, just so that we know when we're getting very close. Not quite there. Okay, 17.08, so good enough. So what we're doing now is just pressing the centre bearing onto the crankshaft, and the seat is fully down onto the bottom of the crank. Like so. So we're now going to fit our new left-hand crankshaft bearing. Before we do that, we need to put the pickup plate back on. That basically just slides over, and there's a little locating pin that will drop in like so. And then we just push the bearing gently down until it touches the plastic shroud. Okay, so we set that up in the press. There's our bearing onto the shaft. So we've got our bearing in, all greased up. We need to just drop the wave washer in, and again a little bit of grease to help that. And then we can drop our crankshaft in. So we can see that the crankshaft turns right. The sprake bearing is doing its job and not letting the crank turn backwards. And that's the opposite to this one. Okay. We built this up just purely for the sake of the camera. You may have noticed while we were building it up that this is the shaft that has got water damage on the bearing surfaces. So this is scrap, we're not going to use it, we've just literally done it for your enjoyment. So in true Blue Peter fashion, here's one we made earlier. So this one has got good bearing surfaces, good bearings, and this is the one that we'll be putting back into this motor. So we've got a crankshaft assembly, we're now going to put that back in the motor. One thing to notice is this large bearing underneath the pulley has to be pressed into this housing as the crankshaft goes in. So there's two ways we can do this. We can get the press and press the whole lot in together, or you can get a small punch and punch through the holes very gently to just tap that bearing down. So we're opting for the press just because we've got one. And there we go. So once the bearing is seated, previously it had small punch marks in 4 positions to hold the bearing in place. So what we're going to do is replicate that in 4 positions again to hold the bearing, and this can be done with a small centre punch. What we're doing is just spreading the top of the aluminium case to secure the bearing. like so. So we put a new belt on. Tensioner. Now we're ready just to pop the top cover on. So refit a cover, a gasket. So we're now going to retension the drive belt. Now everything's back in place. We need to just put a bit of thread sealant on that. Don't get any out. Now, the torque of this belt, the tension, is critical and it is minute. We're using a torque wrench here set at 0.3 Newton meters. The torque specified is 0.25 to 0.3. And that's it. And we now have a motor that sounded like the original. Well, thank you for joining us again at Performance Line Bearings. I hope you found it useful. If there's anything we can help you with in the future, please visit our website www.performancelinebearings.com. We do stock most of the bearings for the Brose motors and some of the belts and parts, but they are limited. We are working very hard to rectify this, and I'm sure in the near future we'll have everything you need. Thank you.